A polynomial inequality is when you have, of course, an inequality, and you could have a polynomial on the left and on the right side of the inequality, or just on one side. And to solve the inequality means to find the set of values for your variable, usually x, that satisfy the inequality, okay, the values for which the inequality is true. So the process that we're going to follow is here. The first thing is you want to move everything to one side of the inequality so that you have a 0. Okay, and then because we have a 0, we're then going to find the zeros of the other side of the polynomial that we have, and we're going to place those on a number line, and that separates our real numbers into intervals. And then we just need to check whether each of those intervals are positive or negative, and then we'll be able to solve our inequality. So let's look at an example of this. Here we've got f of x equals x plus 2 and g of x equals x squared. And we'd like to solve these two inequalities. So we'll start with this first one here, f of x less than g of x. Let's go ahead and plug in what we have. So f of x is x plus 2 less than g of x, which is x squared. Okay, then we're going to move everything to one side of the inequality. I'm going to go ahead and move things to the right side. So I have a 0, and then I'm subtracting x and 2 from both sides here. So we get x squared minus x minus 2. Now we're going to find the zeros of this polynomial, and we can do that by factoring. So we'll factor this. This is x minus 2 times x plus 1. We want that greater than 0. The zeros of this factored form now we can easily get by setting each of these factors equal to 0. That gives us x equals 2 and x equals negative 1. Now we plot those on a number line. We've got negative 1 and then 2. You don't really have to mark every point between. I just mark the values, the actual zeros that I have. And at each of these places, we know that this polynomial here is equal to 0. Okay, so sometimes we'll put a little 0, like we'll label that these are 0 here, maybe in little quotes. Okay, 0 and 0. That's not necessary, but just remember that those at these x values, our polynomial here is equal to 0. Then we pick test points, and we can pick test points for each interval and find if we have a positive or a negative number. So for example, if I plug in over here, say x equals negative 2, okay, and if I plug that into this polynomial here, I could either do it into the factored form or the non-factored form. I'll plug it into the factored form, we get a negative 4 times a negative 1. And this is a positive 5. Okay, and so above that we can just mark that it's positive here. Now it's positive on this entire interval because we know that the polynomial is only equal to 0 at negative 1 and at 2, meaning this polynomial, which we know if we were to graph it, would be continuous. Okay, it can only change between positive and negative if it hits 0. So on the left side of negative 1 here, we know that our polynomial is either always going to be positive or always going to be negative. Since we plugged in a value and got a positive from our test point, we know that it's positive on this entire interval. Okay, then we can try another test point here between negative 1 and 2. So say plug in x equals 0 and see what that gives us. And if you plug a 0 into this, you'd get a negative 2 times 1, which is negative 2. So that's a negative. So this entire interval, the polynomial is negative. And then over here, we can plug in a test point, say x equals 3, since that's to the right of 2. And if we plug 3 in, we get 1 times 4, which is a positive 4. So it's positive on that interval. So now we know that, on this interval, we know the sign of this polynomial for each one of them. Now looking at the inequality that we have, we're looking for when that polynomial is greater than 0, meaning we're looking for when it's positive. Okay, and so we see, well, it's positive here and it's positive here. And we will write our answer in interval notation. So for this first interval here, that's from negative infinity all the way up until negative 1. Okay. At negative 1, we know that our polynomial is equal to 0, but we want it strictly greater than 0, so we're not going to include negative 1. We also have this interval over here where it's positive, so we put our union, and then from 2 to infinity. And again, at 2, we know that our polynomial is equal to 0, but we want it strictly greater than 0, so we will not include 2. So this interval, or union of two intervals, is the solution to this inequality. Let's go ahead and look at this, this second one here, solve f of x greater than or equal to g of x. Now we've done the bulk of the work here because we've already kind of gone through and done all of this work, and the only thing that's different is the inequality here is a different direction, and it includes the equals. Now I'm going to go ahead and write it out real quick just so that we can see that. So we'd have our f of x, which is x plus 2, greater than or equal to g of x, which is x squared. And again, if you move everything to the right side, you get 0 greater than or equal to x squared minus x minus 2. And again, that factors. Now we've found all the zeros, and we already did our number line here, and we know where it's positive and negative. And looking at what we want the polynomial that we have here to be less than or equal to 0. Meaning now we're looking for when it's negative, and we see that it's negative between negative 1 and 2. So between negative 1 and 2. But we also care about when it's equal to 0. We have the greater than or equals to symbol here. So we're going to include anywhere where it's equal to 0, and we know it's equal to 0 at negative 1 and at 2. So we'll put brackets there to indicate in our interval notation that negative 1 and 2 are included in the solution.